Okay, so hello everyone. Welcome to another episode of the DataBri-X webinars. So today we will look at DataBri-X tools. So we have the tool session 3 today. My name is Robert David. I work for a semantic web company. And the tools we will look at today are specifically for data description and data preservation. So to set a bit the context in general for DataBri-X, we have the objectives here to build a user-friendly toolbox. So the toolbox is the main focus of the project of practical, robust, and scalable bricks, which are processes, technologies, and tools, where today we will focus on the tools. And yeah, with these tools, we provide a holistic approach to data lifecycle management in compliance with FAIR principles. We also consider optimization criteria when using the tools, like, for example, minimizing the energy footprint of the tool usage. We also integrate with database technologies. So the toolbox is designed to be applied in the context of data spaces, where we actually have a general architecture for integration. Currently, we focus on IDS as a concrete implementation, but we also take a look at Gaia-X and other options to integrate with data spaces. And finally, being related to semantic web technologies, especially for metadata management in data spaces, we also reuse existing ontologies, vocabularies, and data models in the project. So the DataBri-X toolbox architecture, first and foremost, is governed by a process and application called Champlain, so Champlain Data Governance, which can be used to design workflows that consist of tools that are assembled by Champlain, considering also this optimization criteria like the power consumption. Champlain puts together different tools for different purposes to create these workflows. And then with the DataBri-X toolbox, we can deploy these workflows and put them into operation and execute them using a Kubernetes-based platform called Argo, and also provide monitoring, orchestration, and the connection to the data spaces there while executing the workflows. Yeah, here we see the Champlain data governance process. And as you can see, the tools are grouped regarding their purpose, the discipline. And in today's webinar, we take a look at tools for describe and the tools for preserve. So we will look at specifically at 5 different tools today. So the first tool, which will be presented by myself, is PoolParty Semantic Suite, and specifically a component which is part of the suite called the extractor, which can be used for knowledge graph-based NLP analysis, followed then by the watermarking tool, which will be presented by Devris. And then we have the Open Research Knowledge Graph presented by Alad, and the DataCite Connector presented by Javad. And finally, we have a presentation of RDFox done by Valerio, which is RDFox is a scalable graph database and reasoning engine, providing a data log engine for graph-based data processing. Yeah, and with this, we come to the first tool presentation presented by myself, which is PoolParty Semantic Suite, and which is a semantic AI platform which consists of several components for different parts of the data lifecycle management focused on knowledge graphs and AI applications. And just to give a short introduction of the company, Semantic Web Company is the developer and vendor of PoolParty Semantic Suite. So our focus is the product PoolParty, and where we also provide services around it and build applications on top of it. So we are focused on semantic AI. The basis of PoolParty is knowledge graphs, and here we are focused very much on W3C standards, so the semantic web stack. PoolParty is provided on premises and cloud, and in the cloud, having 170 customers worldwide. And what the platform provides based on knowledge graphs is different components which also implement hybrid functionality together with NLP, machine learning. We create hybrid systems of knowledge graphs and other AI-based approaches. Nowadays, of course, also large language models, LLMs, where we provide, in combination with knowledge graph, semantic RAG architecture. So how does the platform look like? We basically classified our components and features into 4 categories. So as already said, the graph management, the knowledge graphs are always at the core, where you can start off with building simple knowledge models, often as taxonomic structures in a hierarchy, which can have multilingual labels. So you can organize your knowledge in a taxonomy. But if that's not sufficient to represent your use case, you can also extend it using ontologies. So we provide several OWL elements that you can use, classes and properties that you can use to extend this knowledge model to reach an expressivity that you need for your use case. And then you can apply this knowledge model, for example, for text mining and natural language processing. So using this knowledge and especially the multilingual information that you have to analyze various documents and create semantic annotations. So this helps with understanding the content and processing it in a very specific way defined by the knowledge model. And then finally, on top of that, you can build semantic AI applications, like, for example, a semantic search based on the semantic annotations, or a recommender system that relates documents using various graph paths. And finally, the 4th part of the platform is the automation part, graph automation. So when analyzing large amounts of documents and for any other data integration or processing scenario, we also provide an automation part that you can use for ETL tasks. So today, and in the context of DataBri-X, we focus on the extractor component, which is doing text analysis, NLP analysis based on knowledge models. So as already said, you start off with the taxonomy and ontology server, building your knowledge model, taxonomic structures, multilingual labels with ontology elements. And once you have that in place, you can analyze your documents. You get semantic annotations using the extractor component. And then as the 3rd step, you can use it further. Here we see data integration and data linking of these semantic concept annotations, and also enabling semantic search and recommendations. So here we see a screenshot of our corpus analysis component, which uses the extractor to not only annotate one document, but a whole corpus, a collection of documents, and provide a visual representation of these annotations. The use case I will present today is about ESG, environmental, social, and governance, where companies provide reports, they publish reports about their ESG activities, and to assist with providing such reports, understanding the standards and the criteria that are necessary to be fulfilled. We developed an ESG knowledge model. So we have a knowledge model for this use case already in place, which is developed to a high completeness. So it covers the domain very well. And we will use it to analyze a collection of ESG reports, which we already split up in meaningful parts, in meaningful paragraphs, and so we can take a look at that. So, and with that, I will switch over to the demo. And we log into PoolParty and open the project. So here we can see on the left side this taxonomic tree structure. We can expand the tree. So our knowledge is organized in a hierarchic way, from more general concepts to more specific concepts. And yeah, as already said, this knowledge model has a high completeness. So there are a lot of different concepts to describe this domain in detail and very well. So let's take a look at a concrete concept. Here, recycling, which is basically a narrow, more specific concept located in the ESG part of the tree. And what we can see here on the left side of the details are the relations to other concepts in the hierarchy, so the broader concepts and the narrow concepts, but also the concepts that are generally related, not based on a hierarchy, using a related property, which we could also make more specific by using ontology properties, for example, to give it more meaning. The concept is identified by URI, so it's uniquely identified when doing the semantic annotations. Then we will annotate it using this URI. And how is it found in the documents? How do we do the annotations? This is done by the labels showing on the right side. So we have one preferred label for the concept, which is, so the purpose is if you want to show one label for a concept in content, then you can use this as a preferred term to represent the concept besides the URI. But we have also a lot of alternative labels, and all these labels are used to find the specific concept in documents. So it doesn't matter if we find recyclables or recycled in the document, it will always identify this specific concept and annotate it with this specific URI. So this is providing semantic annotations to the content, which can then be used to enable further use cases. And now we switch to the corpus. So we switch over. Here we have again a representation of the taxonomic knowledge model, but already see here a tag cloud for the concept recycling. So what our NLP extractor component is also providing, its related term suggestions, which appear often and with a high score of meaning in the context of recycling, which help with understanding how this concept is used in the corpus. And you can also use these terms and work further with them. So what we have here is, we have here corpora and two corpora. We take the paragraphs corpus, which is which includes the ESG reports, and take a look. A lot of different documents can be found here. We are searching for one specific example and open it. So here we see the document content in the middle. This is the text, so it's a rather short paragraph. And we see the annotated information where we have three different entities annotated. So first the concepts that we have in the taxonomy. We also have shadow concept and terms. But to start with, let's take a look at the concepts only. And yeah, here we see, for example, the concept recycling appearing very big. So it's a quite important concept for this document. And in the document content itself, we can see that it was identified using different labels, but it identified as the same concept. And yeah, with the color coding, the concept schemes are basically the topmost element in the hierarchy, so that we know where this concept actually is positioned in our knowledge model. But this is provided with color coding. We also have shadow concepts here. These are basically concepts that are not explicitly mentioned in the document. So the terms are not found directly. But the context, based on this tag cloud information that we processed, the context is such that the concept actually should appear regarding the meaning of this paragraph. So it has a very close semantic relationship with such shadow concepts, and we provide this information as well because it's usually helpful in understanding the document, but also in building semantic search and recommender applications. And the final part are the remaining terms, where we also provide a structured processing of these textual terms that you can then further use to work with. For example, also make concepts out of them and put them into the knowledge model. So we provide these terms in a refined way, clearing away stop words and such, so that you can get the most out of your content of the documents. So this is basically what the PoolParty extractor is doing, and this component is provided to DataBri-X and used in two use cases to enable bit of different functionality in each of these use cases. So in the first use case, which is about the operator data space, telecom operator, we're annotating the data for providing a call center chat analysis, which is a sort of analytic task. So to better understand the content and meaning of these chats. So we provide advanced analytics there with the goal and purpose to improve the services and thereby retain customers and support growth. And the second use case where we use the extractor is use case 3. It's the legal data space. So here we are in the legal domain, which is a very complex and often difficult to understand domain. And we are annotating here legal documents. And on top of these semantic annotations, we build a semantic recommender system, which can be used to get better insights into the legal information in the documents, but also assist legal experts with working with the documents and understanding the relation between the contents between different legal documents. So these are the two use cases where we provide the extractor as part of the toolbox, as part of workflows which implement these two use cases. So this is basically the PoolParty extractor presentation. And with that, I'm happy to hand over to the next presentation, which is Devris, showing and explaining us the watermarking tool.
Let me share my screen. I hope it is visible. Yeah. Hi everyone, I'm Darvish and I'm a PhD student at IMDEA Networks. And today I will talk about data provenance and the ownership that DataBri-X actually brings out, and how we can actually manage this via our tool, which is Watermarking tool. So for the motivation, I will quickly give a motivation. What do we mean by the data provenance and ownership? So we have a use case in general, and which Siemens is benefiting. Is assume we have an owner, that the owner we will call for the sake of this presentation, let's say a data seller, it doesn't really matter, but someone has some data that owns the data. So in our use case, this can be the Siemens, which has this smart meters generating time series, and this time series is in the form of database, for instance. And this is the data that has been held. And because DataBri-X actually brings out very important functionalities to the systems for the data economy ecosystems and data sharing ecosystem, if you think about the IDSA and GaiaX, for instance. Again, for this sake of understanding the motivation, let's assume that we have a data marketplace that is actually sharing some data and bringing a kind of the bridge between the people who are interested in the data and then the owners. And the data marketplace and owner has some agreement within this space. We call it terms and conditions in general, but I'm not going to go into details of this. And then the marketplace has this all nice the ecosystems with all the data, which Databricks actually think about it as a huge bugs. And then the buyer are interested in this data. And then the data marketplace, actually the buyer gets or the buyer or any entity that actually interested in the data gets this. Again, with some agreement, some use terms of use. It can be some other license agreements, and then they share the data. The issue becomes like when you have this nice example, even though everything is nicely working, everybody's following they're supposed to follow. The issue becomes when the buyer could be malicious person and identity. When we say the maliciousness, this could be maybe malicious reasons or may not be malicious reasons. Maybe there's a data breach happened and the data that they had it legally has been exposed. And this is something that we hear all the time. Now the issue is how we can actually the owner, if it kind of becomes a malicious entity, buyer becomes a owner and it becomes a malicious entity and becomes a party in the system again, acting like an owner, and combines all this data that buyer has and becomes like, here's my new data, even though it was not its data, but just combined many different data that actually purchased it. If you think about it, it could be some horrible use cases, very extreme cases, obviously, that the buyer somehow gets the hands on some data provided by our use cases or some companies, and then try to blend in as a new data. The issue now is to actually protect the owner in here, right? The issue is how we can actually protect, I will call this the identities and Alice, against this kind of privacy and this kind of violation of the intellectual properties. The issue in this system is actually the ownership issue. So if there's a data going around, who actually owns this data? Owns means who actually generated it and put it in the system. And the identity, the entity who puts in the system, we will call it the owner, the data generators. And how we can actually show us that is owns the data. If there's a data, how can I say this belongs to that entity? The proposal was that DataBri-X actually benefits and solves this issue using watermarking technique. And I will go over the watermarking technique and what we proposed and how this watermarking is working. So I will try to be as brief as possible. And then watermarking is not something new that we hear. It has been there for ages. And with the databases, machine learning, all these new data forms bring out the issue again and again. Who owns it? How you actually prove it? And all the time there was a one side which came with the watermarking. And we see watermarking in different applications. Most of the time, they has been used for the copyright management, but also to see if some data has been tampered, for instance. So what is the idea in general? So I will just give a quick the roadmap, how it actually it works. So if someone has some owner, has some data, which is called original data, and some secret, and generates this the data by using the secret, and some creates a watermark data. And during the detection, let's say owner sees some data going around and wants to see if it belongs to her or not. And then use the same secret to see if there is a watermark on the suspected data or not. And the result would be yes, you have a watermark on it, which will be the proof of your ownership, or will not have the watermark, which means that probably you are mistaken. You just suspected, but it's not correct. So what is the general idea? When we say secret, I'm going to say the secret as a high entropy in here, which cannot be guessed by default by any identity. Just you add some distortion to the data set. You just change something on it, without destroying the utility, which is a perception. Perceptual meaning, when we say the utility, it depends on the use cases and where we are using it. So what you do, you use the same secret for the generate and then detection, which that's why we call it semantic watermarking, and it has to be resilient to some certain attacks. Which we call it, like say, destroy attack in this robustness. And then the how actually it's going to work. So I'm going to give a quick example, which DataBri-X, which as an IMDEA we brought it. So this is the solution that we proposed in a conference paper, which we called FreeQVM. So this is one nice quick example that we have, and you can think about this in any cases. So we have a list of some visitors on some of the websites, and you generate you have all your last month visits. The idea is now you create a histogram out of this system, which means that you have all the, let's say, top ranks of your visits. Let's say YouTube was the most visited one, El País was the least visited one. The idea of watermarking on such data sets would be the generation. So during the generation, what will happen, you will use a secret information as shown as a key in here, and we will give some advantage to the owner to decide how much distortion you want us to handle, then which we will call it as a budget. The budget will have the control, the distortion on the data set. The generate is really important because, again, it depends on the perceptual utility, what you want to preserve. And once you create it, you will create another list of the URLs, for instance. As you can see, the blue one says that there is something changed about them, watermark changed something, they added a distortion. The idea would be, which FreeQVM focuses on, you have one histogram of the visits, frequencies of the visits, and the watermarked version. The one that I showed in the color fill here are the ones that distortion edited. So distortion, which comes from the watermarking, is not edited or everything, but somehow edited because of the key and the budget. Idea would be this should be very similar to each other given the budget. How it works in general, the idea is like choose some pairs on the histogram by using the secret, and the function evaluation of this between these pairs that you chose using the high entropy secret should be 0. Idea of the 0 because we propose it should be the 0. So this is high level is how it works. So I will get a little bit more into details. So the idea is we have the original data, and then we have the watermark data, and then we do histogram generation, which is in the case that to generate a histogram. For instance, for the Siemens, we have the time stamps and the values that comes from the meters, and this meters values between 0 to 1, for instance, or decimal numbers, that's actually being generated using the histogram. And then now we say we're going to watermark the histogram. And then we do some optimizations, which are this weird, complicated stuff in here. And it's based on the budget and as well as the high-end secret. Once we've done this, all the optimizations that we do, and then it will create a new histogram again. So as you can see, this color are changing here, which means we changed. So for instance, YouTube was 97 before in the original data. Watermark version says it should be 98. And El País was 53. Watermark said it can stay as it is, but its pair, which is the BBC, should change to 63, which goes down. And then we have the data transformation, which is the original version of the original data. The form should be the same form as original data. And the detection, you just use the secret that you're going to do. There are some kind of the cases that we need. So we want to choose, the more pairs you choose, the more you're robust in the watermark, and considering your similarity, of course. Then we want the robustness, which means any modification you do will not change the underlying watermarking, underlying watermarking. Then we have non-interference property, which means even though you add multiple watermark on it, I should be able to verify it. The reason that we have generated this property, for instance, someone watermarks this and sends a system, and then another person maliciously goes and watermarks again. Now there are two watermarks which has a dispute between them, and you don't want these two watermarks to interfere in each other. For instance, the original watermark should not be removed by other watermark, which is really the case. So because of the DataBri-X, even though someone comes to the system and proposes another data set that has been watermarked by any use case parties, we can still detect this. And it should be secure, and it should be blind. Blinded means that someone's look at the data. We should not be able to need we should not need the original data to check the watermark. And invisible means that nobody should be able to see where the watermark is. So this is different than what we see in general. For instance, when you have a PDF file, it says this comes from some government institutions, it comes from, for instance, Google, and you can see that it's because there is an image of Google behind the PDF file. You can actually figure it out, which means it's visible, and the visible one should not actually guess what is it. Once this has been done, what we have done is actually to see, we want to see that how this actually affects the watermarks. So the idea was the FreeKVM was proposed this nice solution which does not depend on the data. So as you can see in here, when I talk about the visits, and when I talk about the Siemens data sets, which is a different type and different data structure, while in here it's just number of URLs. There's no structure at all. But it didn't really matter for FreeKVM or in our use cases, which actually makes a huge benefit for DataBri-X. So we do not actually depend on the data type. We just need to know what kind of data type and what kind of data structure we are using to be able to generate the data transformation to happen in here. But this knowledge can be derived on fly when you upload your file. So it can be any type of structure we have. So we have, of course, some issues that we because of this agnostic way of handling the data structure or data type, which is really nice, but also we have some drawbacks, obviously, that if somebody interested, I can talk about this more. Again, as I said, the watermarking is always there, so we are not really proposing a new term, but it has been as a term is there, but our benefit was different, which DataBri-X enables this, is the comparing with the other solutions, how the solutions actually being, and why the DataBri-X tool watermarking, which is based on the FreeKVM, is actually outperforms other solutions. So in you can see, you have the very nice graph in here we generated using our use case, our solution FreeKVM that is being integrated to DataBri-X currently. Is that this graph shows, for instance, the original one is how the origin histogram looks like, and this is how the other two solutions that we compared against looks like. So the FreeKVM enables that this histogram will be preserved as much as possible, right? And it won't propose a new distortion to the system because of the budget and then the ranking system we have. And I didn't tell a lot of details about the FreeKVM, how it exactly works, but general idea is to basically preserving the ranking as well as the respecting the budget. one of the solutions, which was really nice solutions from the 2008, there, as you can see, they have very weird pigs in here, which means it's destroying the utility a lot, and which is not really good for the ecosystem, which means you are losing a lot of functionalities and utilities in the data, and you don't have any control as an owner. So in this case, for instance, Siemens cannot actually control this as it please. The other solution that we looked was a different solution. This one was kind of better than the previous one, which is kind of the fuchsia color in here. But it was losing a lot of ones in here, and it has some weird picking in here. And then we realized that it was too much information being lost. As you can see, there's a lot of whites in here, and we didn't want to have it. Still better than the previous one, but didn't really work out. So the last solutions, that what do we mean by the all this very nice, this is the utility, but we want to see what the security means, because even though we say the data breaks in the system, we have a nice control system over the terms of conditions, and we have a secure system to all the parties to communicate by using the connectors, which is really good. But once someone has the data, the attacks becomes offline attack. Not as a part of the system, but you do it offline, this attack in your local computer, or you're running some functions. So in this case, we want to see how this actually can be done. So because what is going to be the good attack, what will be the tolerance of the attack? Because watermarking actually based on the data set itself, and we want to see how we can actually mitigate some certain attacks. There's one example attack I'm proposing in here. I'm looking at it, but we have other types of attacks that we looked. The idea now is the attacking model in here, I will call it destroy attack without reordering. So to forget about the without reordering part, but destroy attack would means you have the data and you create the histogram. Histogram generation is known by everybody, because we don't have the ambiguity in here. So we don't have this. Everybody knows how the system works, how the watermarking works. Just they don't know the secret information in here. So once they have the watermark data in here, attack can start randomly attacking the system, which is a malicious party. This maliciousness cannot come from only the people, but also can happen because of data processing. So you do some data processing, your error coding is not working nicely, and you destroy some part of the data set, which is really happen a lot with encryption was some issues and all these things that happens during the data processing. When we realize that when the attacks happens, the PKVM actually very resistant to some attack types. The only things that we looked to see where is the good tuning of the parameters that we have, that I didn't go into details, was somewhere in here. So we have some idea of how to make the better for the watermarking, which also reflected to DataBri-X. But we still, the issue was how we can actually defining good parameter setting. But this figure actually shows, I know it kind of doesn't mean anything to most of the people, but just focus on this part. Even though you attack very defensive cases, we actually can detect at least more than 35%. The more you include and you increase your robustness level and the accepting watermark level, it actually increases. So this is what threshold means in here, which comes as a parameter, comes with the watermarking technique. As a summary, so watermarking that is enabled in DataBri-X, and DataBri-X actually brings out this any party that is as a part of the data generator or data owners. The Siemens, for instance, for this use case, can actually benefit and protect their intellectual property rights, which is a very fundamental things for the companies. Then the fake VM that is IMDEA brought up to the table was actually one of the most novel watermarking technique that is actually agnostic to data type. We evaluated the security of such solutions against very different type of attacks, which makes also DataBri-X secure against this kind of attacks. Again, these attacks could be offline attack, and watermarking actually protects against any type of any type of the attack that can happen outside of the system. Still, we have some open research questions. These are, again, research questions, also some practical questions, which also during DataBri-X and our communication with the Siemens and use cases, we realized some other challenges that we could actually benefit. They are not really like urgent ones, but these are really nice to look at it, and I would really recommend if anybody is interested in. The one thing is the fine-tuning the parameters, which finding really good values. The other one is analyzing other sophisticated attacks, which means combines online and offline attack and forces owners to be involved. By saying all these things, I'm going to complete my talk. So this is a kind of more introduction of our watermarking tool and how it works. Currently, we have the system designed and implemented, but currently we are integrating to the use cases and to see how it's working. Again, the full development and of the tool will be soon available at the end of the project. And by doing these things, and I would like to thank you all for listening. And if you want to contact and know more about watermarking in general, please visit our website, and you can also send an email to me, and we would be happy to share the information more about the watermarking and how the data provenance is being handled by the DataBri-X. And I would be happy to get any questions if this is the question time if possible. And thank you.
Thank you, Devris, and for showing us how to make your data more secure using watermarking. So thanks. So the next tool that we have is the Open Research Knowledge Graph presented by Arad.
Yes, exactly. So I will also share my screen then and get started. Yes, there we go. Indeed, so my name is Allard Ulen. I'm a postdoc at TIB, mostly working at the Open Research Knowledge Graph, and then specifically human-computer interaction related aspects. So a bit of UI, UX design and development and so on. And today I'd like to talk to you about the features and the APIs of the Open Research Knowledge Graph. So if we have a closer look at what exactly I will be discussing. So first I'd like to go high level and try to explain to you what is the ORKG trying to solve and what sort of issues do we currently have. Then I show you that knowledge graphs are a solution to the problem that I present to you. And then I go into the main features of the ORKG. So I will present to you something called content types that are artifacts in the graph. And I will show how you can interact with them and how they look like in the UI. And then finally, I will discuss the integration of the ORKG, how this works regarding APIs and how you can integrate the ORKG into your own tools. But first, let's have a look. What is the ORKG trying to solve? So as researchers, you know that when you write a paper, you do this in a sort of narrative document-based form. So you have been doing research, now you want to communicate your findings to the community. And the general format is paper-based. So you write your article and you send it around and hope others will read this. This is, of course, heavily focused towards human consumption. So humans are pretty well able to consume this. They can read the article, they understand the flow. But for machines, this is definitely a bit harder. So it's sort of lacking the machine actionability, the research. So it's specifically focused on humans. So what is the consequence of that, or what's the problem now? We can see in this example, if I use Google Scholar to look for something, so I want to find a certain research problem, so author name disambiguation, and I want that using a specific method. So in this case, using graph embeddings. You can see that I have over 18,000 results that are all matching those terms, even though there are not 18,000 papers that are actually doing this, since this is a quite specific task here. So this is sort of the result of having this narrative document-based form, because we're now just doing a keyword lookup to find what matches there. And why is this the standard? Well, if we look back a bit, we can see that a paper that was published several hundred years ago still looks remarkably similar to a paper that's published nowadays. Of course, now it's digital, so at least we can access it on our computers, but still the same format is used. Even it still looks like a paper, but then just in a digital form. So this is exactly what the ORKG is trying to change. So we're trying to provide machine actionable scholarly knowledge, so machine actionable representations of papers, and basically ultimately providing fair scholarly knowledge there. Here we can see that results in something, that is a scholarly knowledge graph, hence the name Open Research Knowledge Graph. In this case, we can see an example. So there is a paper here that addresses a specific research problem, in this case, COVID-19. So we'll use this as a running example from now on, COVID-19 reproductive number research. Here we can then see numbers that are presented, so the basic reproduction number and a confidence interval. Then there is a location where this research is conducted, and there's a DOI of the paper and some authors. So if we now have a closer look, we can see that the DOI and the authors, we can consider them metadata. There's already quite a lot of systems out there that do the organization of scholarly metadata pretty well. But looking at the actual data that is basically added as a contribution to the community, we can see that this is pretty unique. So not a lot of research is described in such a way where you can actually access the data that's presented in an article and access ultimately the knowledge that's presented in the article. But if we would have such a representation, having this search query where we can say, okay, select all papers that are related to the COVID-19 reproductive number and do this for certain locations or find the locations, we can easily get a set of papers that is much more fine-grained search. So we don't have tens of thousands of results here. This will be much lower because we're having a very targeted search here. But in order to do this, first we somehow need to transform those unstructured papers into the structured representation. And that's, of course, the big challenge here. And that's the challenge that the ORKG is facing as well. So what we are trying to do here is we have a relatively unique approach, I think, where we're trying to include crowdsourcing. So we're trying to include researchers, authors, and so on into the process of transforming this knowledge. And we're trying to have assistance by artificial intelligence. So, of course, those crowd workers or the people contributing, they are most likely not familiar with semantic web technologies. They might not know what is a knowledge graph and so on. And that's where the AI comes in, where we are trying to assist users, trying to recommend what sort of properties to use or what sort of predicates to use, and how to properly structure your data, which then results in this structured knowledge graph. So this is the high-level overview of what we're trying to achieve with the ORKG. And how we are doing that, I can show you now. So in the main features of the ORKG, so I will go through some of the features from a UI perspective, so what users can do. But in the background is all results and contributes to building graph. Here we can see 5 content types listed, as we call them. So they are sort of graph artifacts. So they live in the graph, and also they are related to each other. So you can start from a certain content type as a goal to then move on to other content types. That's why we see the arrows in between the content types there. So let's start with a list. A list is not yet that much structured data. So here we can see an example of how that looks in a graph form. So we can see an article, and then we can see basically only metadata here related to the article. But this already helps structuring and organizing knowledge a bit, because we have a list where we can group articles that are closely related to each other. For example, articles that address the same topic, and it's then possible to create subgroups to better organize them. Apart from papers, it's also possible to add software to it or data sets. So it's really sort of curated lists, as you sometimes find them online, of interesting papers. If we now have this list of papers, so let's assume we have a list of COVID-19 reproductive number related papers, we can now start to describe them in a structured paper form. So here we can see we still have the same metadata graph, but what we're adding now to it is actual contribution data, meaning that suddenly we have papers in a graph form. Here we have an approach that describes the R0 estimate and this location. And this, of course, is a very simple example, and it really depends on the use case whether you need such a simple graph or a more complex graph. So it is possible to use any ontologies in the ORKG, so you can properly describe this, so to say, but for some use cases, such a simple graph structure would also work. Also, we support templates here, and templates help to describe the same structure for papers that address the same topic. So they are based on the Shackle specification, so they are creating constraints on what data you can add for a specific paper, and then it's possible to describe them all using these same templates. Once we then have papers that are described in a similar manner, we can put them together in tabular form, and that results in something we call comparisons. So here we can see there is a comparison that has papers listed, and they are really a tabular overview of papers that are addressing the same problem, but are most likely resulting into different results. So in this case, if we zoom in a bit, we can see there are 4 papers listed. So there are 4 columns, and there are some rows here that represent the properties of the papers. So we can see they all address the same research problem, so all COVID-19 reproductive number, but they have a different study date, a different number, of course, and also a different location. So this really helps finding and putting research next to each other. So something we also generally recommend users to do is to create such overviews of literature to structure your related work section in your paper. So generally, you compare papers in textual form there, you try to explain what they do and how they are different to your work. And one nice way to then summarize that would also be in tabular form like this. So they are focused on customizability. So you can change the table, you can add properties and remove them, transpose, add additional columns and so on. And of course, very important, also the reusability. So it's possible to assign a DOI to a table, which means that we create a snapshot that's persistent, so it cannot be changed by others. And then it's also suitable to cite within an article as such. Once you then change it again, you can publish a new version and assign a new DOI to it. And then the previous version will also link to the newer version. And of course, we have several export formats as well. Sometimes a table is not the most suitable way to visualize the data, especially if you have numeric data. So then we also support something called visualizations, for example, bar charts, scatter plots, and so on. So just different way to visualize the table or the data in a table. Finally, it's possible to combine all those content types and put them into a sort of dynamic literature review. In this case, you can see it consists of papers that are represented in a comparison, and then we added some review-specific text on top, which finally sort of results in a dynamic literature article. And one of the benefits here is that it's possible also here to update this over time. So when new work becomes available, it's possible to quickly and easily update this version, sort of addressing the issue that currently many review articles have, that they are outdated soon after they are published. Finally, I will quickly look into the integration of the ORKG. So here we really saw some user aspects, so users interacting with the ORKG and that don't have any technical skills, so to say, but also it's possible to integrate the ORKG into external services using APIs. So the front end, so the screenshots I just showed you, they're all using the backend, which is a REST API. And for those content types, it's possible to easily get them or to update them and so on. So here we can see we can just access a paper with all the related data. The same applies to review. So we have the review related data, including the sections here and what content is in the sections. So this is all available in such a JSON format, but also in a more structured format using the Sparkle endpoints. So we can query, in this case, we can see what kind of comparisons there are, and we can access the data within comparisons as well with the Sparkle endpoints. The endpoint is updated every 24 hours because we're currently using a Neo4j knowledge graph. So we are exporting this every 24 hours to make sure that people can access the data in the method they like. Finally, we also have an ORKG widget. So you can add this in a web application, for example, and that works by providing a DOI to the widgets. If there is an entry in the ORKG that matches the DOI, you can directly visit this page and you will see how much statements are made about this paper. Or if there's no entry, you can, by clicking the button, quickly add this to the ORKG. And then there is a Python package which sort of is a wrapper for the REST endpoints. So you can, also when you're doing data analysis and so on in Python, you can access the REST endpoints using the Python package to also directly add your content to the ORKG. That's it from my side then. If there are any questions, you can ask them. Also, you can send me an email and just contact me. And you can have a look at the team page. So we are a relatively large team working on the ORKG. And then I think we are moving on to Jawat's presentation.
Yes, thank you a lot. Jawat, please.
Thanks.
The stage is yours.
First of all, sorry for my camera. I will turn it on for like a minute and then turn it off because it's still flickering. So let me share this screen here. So hopefully you see the screen now.
Yes, it works.
Okay, good. So thank you very much for this webinar and for attending here. My name is Jawat Shamanara. I'm actually leading some tasks and activities in DataBri-X project. In the DataBri-X project, we are providing multiple tools. One of them was this connector to ORKG that Allard has just presented. And the next one is this DataCite Connector that I'm presenting here in a very brief. DataCite basically is an organization and a tool, or let's say is an ecosystem of the tools. As an organization, DataCite is a global community-driven organization that wants to actually to prove visibility and accessibility to the data. Like, for example, you have DOIs for papers and so on. They want to do it for research outcomes like data sets, and also research inputs like the source of data that you need for your research. In some cases, it can be also used for applying DOIs on the processes, and so that you can actually maintain whatever that you do for your research. It has been founded in 2009 with different stakeholders, with different membership scenarios. But in general, this is like a membership organization that people go establish a membership, accept some responsibilities and so on, and get access to the facilities that are there. As I said, its main, let's say, objective is to provide DOIs for research data, which means that the data set that you use for the research, or the data set that you produce as a result of your research, or any data paper that you actually explain your data set in it, they can be good candidates for getting this kind of DOIs from DataCite. So this organization, as I said, is based on memberships, and membership are diverse. Diverse here means that diverse in terms of functions in the organization that are members, diverse in the membership type, which means that what they provide to the consortium here, and also geographically, they are very diverse in Europe and North America. The whole idea actually has started, as I said, in 2007 and was registered in 2009. It was basically a result of a research meeting here in Hanover, led by TIB, with a lot of other members thinking about how to make data sets persistent or discoverable over time, and also how to make them somehow unchanged for a while, so that if I'm using your data 5 years after you have published it, I should be sure that I'm still using the same data because of the reproduction, because of the provenance, and so on. So in general is that there is a data site that accepts membership. Members are normally institutions. They usually have their own data centers. These data centers are hosting the data sets, but they want to actually assign DOIs to those data sets. Basically means that when you register a data set, you will get a DOI. That DOI will be referring to a landing page. The landing page can be hosted on DataCite or can be hosted on the member institution. But when somebody clicks on the URL of that DOI, they will actually be redirected to the landing page. And then in the landing page, you see some metadata about the dataset and also access to the dataset itself. It doesn't mean that the datasets are open or free. It means that the landing page of them is open and free, accessible. You can read about the data. If there is an access policy or copyright or pricing or whatever, you will also see it there. It may need the registration, for example. It may need the money transfer or whatever that is written in the license or copyright of that data set. But at least you know that this data exists and there is a way to access it. And more importantly, it is guaranteed that the data set will remain there unchanged for a time period that is by default 20 years. So in this case, usually is that there is a DOI minting process. Basically, this is when someone is requesting to acquire or to obtain a DOI. In this case, one of the member institutes will provide an DOI minting facility for its members or to the public based on the responsibility that the member has. Like, for example, in TIB, we are providing that for almost everything publicly, but in a specific domains, like in mathematics, natural science, and so on. So we don't provide DOIs for, let's say, social sciences. Possibly other organizations are doing that. But you can also be a member that is providing DOI for its own, let's say, employees as a university or as a research center and so on. So this DOI meeting has a process. You will provide some metadata, like, for example, the bibliographic information of the data set, something about the content of that data, something about access rules or copyright and so on. And then you request a DOI. That will be automatically validated by the data site. And also someone will look at that. And then you will receive the DOI so that you can use it. And the landing page will be set up for you, either at the data site or at the member organization that has accepted your request. From the other side is that when you have the DOI, you can register metadata. Basically, the DOI comes with a minimal metadata that I will show a little later, but you can enhance that or even change that without changing the data. And then based on that, you have the DOI, you can get citation on that, you can use that as a referral system, and also you can use that as a provenance mechanism so that every time that DOI can be ingested into some like APIs or data integration tools and so on, so that they can fetch not only the metadata, but also the data itself, and then put it into the workflows or data pipelines. So as I said, DOI meeting is basically the creation, the process of creating a new DOI. This can be done for various research outputs, like including dataset, preprint, or even a software can receive a DOI. A workflow can receive a DOI. The input data of a workflow or a tool can also receive a DOI, and so on. Then all the functionalities and characteristics of the DOIs that you receive for papers are also applicable here, and they are guaranteed to be available. So for metadata registration, you can actually do the registration at the time of minting a DOI, or you can do it afterwards. And also there is a life cycle for this so that you can change it over time. Like, for example, if a contact name has changed or a phone number, or I don't know, any other things have changed, or the copyright or access right have changed, you can update the metadata and still use the same DOI. All this registration or changes are maintained in the history of that object that are associated to the DOI. So basically, I don't want to repeat this, but all the benefits that you get from a DUI for a paper or any other object, you can receive it also here. So among the main functions that can be actually allocated to DataCite or assigned to DataCite is that interoperability and integration, which means that you can build different systems, which I will show one or two of them later on, is that tools can operate on these DUIs, for example, to automatically assign more metadata to it based on the processes. Let's say, for example, if you have a publishing house, this publishing house can automatically mint DUIs and publish landing page with metadata and so on through the APIs of DataCite. There would be and already are different metadata standards. At the moment, DataCite has its own standard, but also accepts some other well-known standards. There is a community that are working on this standard. So if somebody is interested in that, they can join those communities and actually contribute to the development of the standards for the metadata. And there are a lot of tools and APIs that you can use for data discovery. Basically, it means that there is a search mechanism through APIs and through web pages that you can use to find out the data sets using the metadata that has been registered in the registry. And this metadata, as Alar showed with the sample of the structured extraction of the data papers, here they also have bibliographic network between them. So for example, if you are searching like a data set that has been developed by me, for example, you can potentially find out what else has been also produced by me or what else I have contributed to the data site. So there is also a graph or a network behind the scene that can be used for the discovery. Okay, as I say, there are different tools that people can use to interact with the DataCite API and database to register or to request a DUI and also to register metadata or to get information about their membership status and so on. So this DataCite Fabrica is the default client tool that has been promoted and used by the members. Basically, this is like a desktop application. I guess they have also a web-based version. But here you can see which organization do you belong to, how many the DUIs have been allocated to you, because there is also a budgeting on that, like 10,000 per year or something. There is a little bit of contribution fees and this kind of accounting information that is available there. But in general, the core is that using this tool, you can see what DUIs have been published by your organization. If you can mint or request another DUI, and if yes, the procedure is available here. So you can basically create a new or request a new one, provide the metadata in a form, and then follow up with the status of that DUI. There are also search or discovery mechanism built into the tool, so that if this is installed, for example, in TIB, we have this, and many people are using it that are managing all the DUI space for TIB. They are dealing with that to find out whether there is a broken link, if there is a new update for a data set, if something has changed in the metadata and so on. They accept this thing, screen them, validate them, and then apply them to the central DataCite API and database. So let's say, for example, titles, author, description, keywords, this DataCite metadata schema, and also Dublin core. This is also like a more generic schema for metadata registration. They are all supported, and based on the organization requirement, the minimum requirements of DataCite, and also the type of objects that you want to register, some parts of this metadata will be mandatory, some parts will be optional, and then the procedure will actually check them all. There are also other clients like this EasyID or metadata from Crossref. So Crossref is also capable of actually minting DUIs. EasyID also but I would say the dominant one is still the Fabrica. So as I mentioned, DataCite also provides APIs, which basically provide the facility to programmatically interact with the database. So in this case, you can write a program that is calling some other functions on DataCite servers to either mint a new DUI or to fetch some previously registered DUIs to get some information on that, and also to apply edits and changes if there is anything. So whatever you do with the desktop client, not all of that, but some stuff that is publicly available, so that you can actually use them in the integration flows, like in a Python code or in a workflow. If you are using Talent, for example, to integrate data from different sources, you can plug them into your tool chain of choice. Like, for example, for DUI registration API, you can allow users to register a DUI, providing title, creator, publisher, publication year, resource type, and additional metadata based on resource type, and then actually send them via HTTP request to the APIs and get the response back, and then be sure that it will appear in the landing page for that DUI later on after approval. Some of these APIs are not openly accessible because this is a membership system. So you should use API keys and other credentials from your member organization, put them into your, let's say, client code or integration workflow or whatever, and then they will be submitted alongside with the REST API, just like the others. The server side will check them, and if everything is valid, they will accept your request. Like similarly for metadata query API, basically you can define different queries, and based on that, you will get a list of DUIs matching that query. And then in the list of return data, you will see, again, title, creator, publisher, or whatever that is registered for that DUIs. The usual scenario is that you will do DUI registration, I guess, routinely, but from time to time, for accounting purposes, for example, for auditing purposes, or for quality purposes, you will do metadata queries on different parts of your DUI space to see if everything is okay, or if you are promoting them on like a public web application, then this query result will appear on your website. For example, for statistical purposes or for demonstration or for whatever reason that you have. In DataBri-X, we have created a wrapper for this. This wrapper basically is like a Python client that is calling DUI minting and DUI querying. What we want to do with this is that to automatically assign DUIs to the data sets in the workflows that we have. Let's say that we have a workflow, as Robert just showed, with the the network operator. When they are analyzing the text, for example, and come up with a data set during the workflow, if they need to register that workflow and keep it for a long time, they may need to assign a DUI to that. In that case, they can call the APIs of our client to talk to DataSet APIs through TIB membership credentials, receive a DUI, assign that DUI to the dataset in the workflow, and then save it somewhere or publish the landing page. The same thing can be done for the workflow itself, because some of the workflows are well-known workflows that can be repeated by other parties, or even they can be published for reproduction purposes. In that case, that would make sense also to assign a DUI to a workflow and then publish it as a matter of provenance and reproduction. This can also happen for the data set that don't have a DUI, but you want to use them in your own flow or in your own tool, but you want to make sure that everybody that is running your tool will access the same input data so that your result will be same every time. Or you can reproduce the results not only on your organization, but also if someone takes your code somewhere else, even in another country, and they run it there, you want to make sure that your code or your algorithm receives the same data. In that case, maybe you put your input data online somewhere, hosted somewhere, and assign DOIs to that. Or even if the data is in a data space, you can assign a DOI to that data space through the APIs that is provided by the data space. In that case, inside your code, instead of working with a local file or with, I don't know, a URL or whatever, you will work with the DOIs as input. You will fetch them at the time of executing your own code, and then you are guaranteed that you will receive the same object every time. This is the thing that we are using in, or we intend to use in DataBri-X, and I guess that was the last part of my talk today. Thank you very much. Over back to you.
Thank you, Javad, and for presenting DataCite. And with that, we come to the last tool presentation for today. And I hand over to Valerio, who will show us RDFox, graph database, and reasoning engine.
Thanks, Robert. I'm just going to share my screen. Hopefully you can all see this. So RDFox is one of the tool providers inside DataBri-X. So let's find out a little bit more about RDFox. So RDFox started as a research project out of Oxford University, and it was spun out as an independent company. We've got many, I'd say most of our founding team has a history of being professors at the University of Oxford. One of them you can see cited here, Ian Horrocks, a very famous voice in the semantic web. And what RDFox is all about is being a very fast graph database, a knowledge graph database, and also a semantic reasoner. As you can see here, we've already many enterprise clients and venture capital investments. I won't go too much into that. And here we can sort of discuss a little bit, what does RDFox do on a conceptual level? Okay, so if we leave aside the graph database for a bit, what we aim to do is we aim to make it possible for organizations to answer questions that are really important to their business. And typically we find that this is difficult because the data is just in too brittle and inflexible a format for those questions to be asked effectively. So eventually you end up not being able to ask questions that are useful in a way that's convenient. So you will ask questions that are less useful, and therefore you will not know some of the things that you should know in business. Now, how do we do this? Well, the first part of how we do this is by creating a knowledge graph, or rather, I should say, storing and querying a knowledge graph. So we don't actually do the part of creating the knowledge graph. We're just a database, so we store and retrieve. But then on top of that, we have the ability to imbue this knowledge graph with human knowledge in the shape of reasoning. So basically a set of rules that are applied to the graph automatically by the system, so that when we ask a question to RDFox that may have several layers of abstraction, RDFox will interpret those layers of abstraction and give the answer that we're looking for. Very simply, if we ask, if we categorize some items along leaves of a taxonomy, but we want to ask questions at a higher level of the taxonomy, we'll be able to do that. Okay, so next up, here we can see about knowledge graphs. Knowledge graph is very simple. It's a collection of nodes and edges. You can think of as that, and we link the edges to one another using some meanings that they have, and we're able to navigate what the objects are and what the relations are between various objects and so on. Is this, I guess the term knowledge graphs first came into popular use, or I should say technical use, when Google published their own knowledge graph back in, I think it was 2012. So Google uses knowledge graph to make relevant information about entities accessible in a very easy way, so that you don't have to click on the link and then find the information out for yourself, but you have what you see here, a knowledge panel, for instance, for Ada Lovelace. Now, of course, the key thing here is that different types of entities will need have different important information. So for a person, it will be when they're born, when they have died, if so, who their parents are, who their siblings are, and so on. But for some other people, there will be for some other entities, there will be different salient pieces of information. Like for a book, we could say who is the publisher, who is the author, how many pages does it have, and so on. So knowledge graphs offer a really great way to store in one place different information about different entities that wouldn't really easily fit into a unified schema. So knowledge graphs have seen a very large adoption in recent years by small companies and large enterprises alike. They can in today's world, they can also deal with very large quantities of data, and there are also some inherent advantages that, as I've touched on earlier, to using graphs over relational databases or other NoSQL databases. And these involve things between from reducing query complexity to reducing energy and infrastructure costs. Of course, you're very welcome to take a look at our documentation and our website to find out more about this. So earlier I talked about the graph part of reasoning and why it's the graph part of RDFox and what it does and why it's useful. But I also mentioned the fact that there is what we call reasoning in RDFox. Okay, and what is reasoning? Well, reasoning is the means by which we let humans, typically experts, pass their knowledge onto the machine, onto the database, so that the database can use that knowledge and together with the data produce answers that will incorporate the ability to abstract concepts away. So you can think of this as basically materialized views in SQL, or in short, the ability to sort of write code that enriches the data, but it's 1,000 times simpler, and it doesn't really require any, and it all comes together with the tool, which is why in DataBri-X we're so keen to which is why we're so keen to be a part of DataBri-X, because there are lots of scenarios like this where there is some data and there is some expert who needs to add their expertise to the data before the data is useful, and RDFox is a perfect way to do this. So here you can see some of the features that advanced reasoning has. And if we go further down, we can take a look at the architecture. So RDFox on its own has several features: command line interface, persistence, the ability to be highly available, so for mission critical applications. And then there is a query engine, which you can see here as Sparkle API. There is a reasoning engine and various other endpoints. RDFox, of course, can, in terms of integration, it can take Sparkle, has a REST API, and it can also deal with external data sources in CSV or SQL or Solr format and many others. In terms of operations, we can run RDFox as a RDFox exposes a user interface that gives us nice visualizations, but also the ability to explain why it's made inferences. So the ability to see what bits of expert knowledge and what bits of data come together to form an enrichment of the data. And in terms of the deployment, it's also possible to do this from anything. It's possible to deploy RDFox on anything between a huge server to a very small Raspberry Pi type device. And of course, RDFox is used in all sorts of applications, like as part of a visualization engine, or to perform analytics, and also in just very simple applications that need a database, whether on edge or on server. How does RDFox work? Well, what does a typical workflow for RDFox look like? Well, so typically some data will be loaded. In DataBri-X, this data, some of it will be provided by the use case partners directly. Some of it will be provided through PoolParty, and some of it will be provided by other partners. So we will load the data into RDFox. Then we will codify the knowledge of experts in rules, which goes back to what I was saying earlier with reasoning. And we'll put these rules into RDFox, and then we have an option of persisting the data. And then when that's done, we can query RDFox in a highly scalable fashion, and hopefully answer all the questions that are required. Now you might say, what happens when new data comes in, or what happens when the rules that we had need to be updated and so on? Do we need to reboot the whole system? And the answer is no, actually. Thanks to what we call incremental reasoning, which is powered by patented algorithms, it's possible to make changes to the data and the rules in RDFox such that we do not need a full reboot, but rather the changes happen incrementally. So this has the advantage of anything between just making your developer's life a little bit simpler to being available in a sort of a novel type of use case where you have a sort of where you remove the need for a pipeline altogether, and you give to users the ability to have a live system in which their rules and their data produces an immediate feedback. So we have many clients for whom this is very important. Yeah, and then this is of course done in a how shall we say, in a way that is friendly for database admins. So guarantees around consistency and transactionality of updates, and of course access control, so that we can make sure that certain users only see whatever is required for them to see, as opposed to the whole database. And finally, there are facilities for validation. One final example. This is something that we've done in the past. So outside of DataBri-X is an example architecture of how RDFox works with PoolParty. So what we did was scrape some website data using PoolParty. Then PoolParty annotated this data, which, as it happens, was recipes, and then together with the annotated recipes, we've put a taxonomy into RDFox, and then on RDFox we've built we've used RDFox as the engine to power an app for food recommendation. that was better than the app that where we scraped the data from, because it just had the ability to understand things like the fact that salmon is fish. So if I'm looking for a fish recipe, the previous engine would only tell us about recipes that contain the string fish. So a recipe that contains salmon would be ignored. But with this approach, so creating the knowledge graph using PoolParty and then enriching it, storing it and enriching it using RDFox, with this approach, we were able to sort of improve on that. How is RDFox going to be used in DataBri-X? Well, here we'll tackle two main use cases, the energy data space and the legal data space. In terms of the energy data space, there are some issues with data quality that RDFox will be used to fix. And also it will enhance the findability of relationships in the data that we have. In terms of the legal data space, RDFox will be the backend for PoolParty. So basically, a PoolParty will annotate and act as the main search engine for anything related to the legal data space. But then RDFox will be the high performance engine behind it, and it will store annotations and taxonomy, and also possibly advanced reasoning to perform things like aggregation and negation and so on. That's it. Thank you very much for your attention. And you feel free to find me on LinkedIn or on Oxford Semantic, or at my email, valerio.koshi@oxfordsemantic.tech, or indeed to look at our website. Thanks very much.
Thank you, Valerio. And thank you to all the presenters for showing these 5 very interesting tools today about data description and preservation. And now it's time to take some questions for these 5 tools. Okay, I have a question for the watermarking tool. Devris, you said that the watermarking can basically be applied to any kind of data, so it's a very flexible approach. What about machine learning data? How does this affect if I use my data for machine learning algorithms?
Yeah, so the watermarking techniques, as I said, works on the data itself and has to put some distortion. So this distortion, again, is kind of perceptual utility. It changes some data somehow. And it's good questions because nowadays machine learning models need this data and being used all the time. So data is not just data, but you use it. So we had some analysis when we proposed the solution to see how actually been, when we have the original data and we have watermark data, and we trained the same model with the same parameters and to see how the accuracy is changing. For our technique, actually it improved very little bit because our data itself actually increased in terms of size, and we had to add new labels because of the watermarking. Distortion was basically adding. But in other analysis, again, we had another paper, and that analysis, we watermark the images that are being used for machine learning models. That time we see very little decrease in the accuracy. So that's why it's a kind of very hard question to answer. So we need it depends on the data, it depends on the watermarking. So there is no simple example because we have 2 different use cases and 2 different results. So we need very intensive analysis and very experimental result to see it. So it totally depends on the technique. So yeah.
Mm-hmm. Okay, thank you.
Yeah, I have a question for OKG.
Sure, please go ahead.
So did somebody raise a hand? Or? Yeah, great. So what's the easiest way to get started with it? I'd be really interested.
That is a Good question indeed. So we really have the front ends that you can access using the website or kg.org. And there you can basically create an account and get started by describing some papers. So generally, I would say the easiest way to get started is trying to create this related literature overview in form of a comparison. So take some of the papers that you described in one of your own papers in the related work section and try to add them to the table and try to find some common properties that those papers share. That's the easiest way to get started regarding contributing. Of course, using the website, you can consume the content without any account, and you can use the ORKG in that way as well. But contributing-wise, I think the easiest way is to get started with a small comparison, try to add some data and so on. And I think, I hope at least that it will be interesting to use as well for you.
Thank you.
Thanks. I also have a question about ORKG. And that is how fast do new research papers get into the knowledge graph? So what kind of governance process is there? So you said it's based on crowdsourcing, but so is there some approach behind to do that in a structured way, or which kind of sources do you take, or in general, how long does it take from a paper being published until it ends up in the knowledge graph?
Definitely interesting question. So we don't have a structured way in the sense that we say, okay, it will take 3 months before your paper is there, because we really rely on crowdsourcing in the sense there must be a human that says or decides, okay, I want to have this paper in the ORKG. And that means that if the specific paper doesn't have enough interest, then it might not be added to the ORKG initially. So we are currently also looking at some alternative approaches, of course, with large language models, trying to see if we can already add some initial data, so to say, and then maybe change that a bit. So maybe the users validate that knowledge and then it becomes part instead of having the user basically initiate the process. But right now, there is not really a structured process where we say, okay, we want to have these articles in there. So what we currently do is really bottom up. So we talk to researchers, we say to them, okay, what kind of literature analysis are you doing? And quite often we find that people somehow keep a spreadsheet. So they say, okay, we have these articles, they are related, and we extracted some properties. And especially those cases, they are very suitable to be imported into ORKG to publish those lists and to make sure that others can also use this. And I think that's sort of the most structured approach, but we don't have an outlook right now, and we don't even want to have all papers in there, so to say, because we really, we acknowledge, okay, we need high quality data descriptions, and we know that won't be easily possible for all papers out there.
Yeah, definitely makes sense. Yeah. Okay, thank you.
So Robert, I have a question on PoolParty.
Sure.
The question is that if somebody wants to use the PoolParty, let's say, suite in a completely new domain, like for example in aviation, do they need to somehow provide training data or a corpus that knows those entities and the shadows entities behind them and the relation? Or, I mean, do you need some sort of setup data set, or how is it?
Yeah, that's a good question. So I mean, there are different approaches that you can take on that. So often, if you have an enterprise scenario and you have a lot of documents inside your enterprise or any organization where you want to build systems for, and you have this a lot of textual data already, we provide the tools that you can analyze it, basically starting from the text, getting out important terms for the domain, and then building your knowledge model. So you can incrementally build that up. Then analyze the documents that you have and continue in iterations until you get to a complete knowledge model. So this is one way of doing it, which is this route is often taken because documents are often there. And you don't need all of them, you just need a representative set, can even be a small one, but should be representative of the domain so that you have everything in there. And then you can incrementally build your knowledge model.
Okay.
But also, for example, like I showed for the ESG domain, this is a knowledge model that Semantic Web Company provides. This is ready-made and you can use it immediately. And similar to that, you can also use other knowledge models that are published because PoolParty is based on semantic web standards. So what we are using is RDFs, COS, OWL. So these are all standards that are openly defined by W3C, and published knowledge models often follow these standards. And as long as they do, you can just import it into PoolParty and start working with that. And that's actually encouraged. So the idea of reuse, especially regarding ontologies, is encouraged that experts publish an ontology for a domain and others can reuse it. So the idea of the semantic web is also to reuse this published knowledge using these open standards.
Okay, thanks.
Welcome. Okay, I would have another question, which is maybe a bit a more general one, or let's say even strategic one, regarding RDFox. So RDFox is focused on knowledge graphs, of course, but nowadays we all have these topics of the large language models of LLMs. So what are the ideas and approaches that you take on that? It'd be interesting.
Yeah, no, that's a great question. So you might have heard that, actually, sorry, let me start with the good news. I think LLMs are really good at understanding what humans are trying to do and say, and also generating content that looks good to a human. But the problem that they have is that they're not good with factual information, right? And it's the same with humans. If you ask me, when is the birthday of such and such, I have no way of knowing. So in my case, I know that I don't know, but in an LLM's case, it's very easy for it to sort of make a random day that sounds sensible. So the approach that people have come up with is to put an LLM in front of some sort of database, right? So you would ask a question to the LLM, and then the LLM will sort of understand what parts are important and how to use them in a query, the structured query against the database, and then it will fill in the gaps with the data from the database. Now, of course, the problem is, or rather the question is, what database should you use behind an LLM? And we think you should use a knowledge graph for two main reasons. The first is that a graph doesn't really have a schema. So when you create the data that you put in the database, you don't want to be constrained in terms of engineering and capabilities and so on by just having this big schema that you've got to fit everything into, which may or may not work. So a graph is perfect for that. As I mentioned earlier, you can represent all sorts of different entities very simply. You can talk about books, you can talk about people, you can talk about companies, you can talk about, the bank statements that you have. Anything will fit, and you can link it together. The second reason why I think graphs are so promising when combined with LLMs is that, especially as concerns reasoning, graphs offer you reasoning, and reasoning gives you a tool to just sort of increase the size of the target that the LLM has to hit. So basically, the LLM is going to do its best and run a query that it thinks might work. But with reasoning, we can make sure that there are more queries that work. So, for instance, let's say that we have something some data like William has father Charles. Now we ask a question to the LLM like, who is Charles' son? Now the LLM doesn't necessarily know data as has father instead of has son. So if the LLM asks who, start with Charles and go down the has son route, we won't find anything. Instead, it should have started with Will and then go down the has father route, but it can't know that, right? And this is just the simplest example. There are lots more. Whereas in reasoning, we can say, well, actually, the two are sort of the same, except they're reversed. And it's a son if he's male, and it's a daughter if she's female, and it's a father if it's a parent and he's male, and so on. So the reasoner just makes it much easier for the LLM to return some answers and also the correct answers. I hope that helps.
Mm-hmm. Yeah, okay, thank you. So if I understood correctly, you're basically doing the querying and inferencing still in the graph database, while the LLM provides a sort of interface between the user and the actual query engine, right?
That's right, yes. And it can also be used to create the graph. So you will say, here's a long text, fit this into a graph or represent it as a graph, and then it will put it into RDFox. And that's also why not having a schema just takes a very big obstacle away from the system.
Yeah, makes
Great
sense. Thank you. Okay, I think we're coming to the end of today's webinar. So thank you again for all the great presentations, and also thank you for the interesting questions. And just as the last step before we close, I would like to announce the next webinar that will take place soon, on June the 11th, 24, where we look at unveiling tools contributing to DataBri-X use cases. So there we see more specifically how we apply the tools for the 3 use cases that we have in DataBri-X. And yeah, thank you very much for joining. I hope it was interesting, and see you next time. Thanks.
Bye.
Thank you.
Thanks very
Bye-bye.
much.
Bye.
Thank you. Bye-bye.